The purpose of this video is going to be to walk through an example of building a Spring Boot-based application using a Maven build system that makes use of OpenAPI for RESTful services, Cassandra for NoSQL-style data storage, and Kafka for event publishing and message receiving. Looking at the README, I've left some of the basic instructions for setting up both the local infrastructure and then running the actual app. We're going to start with the infrastructure, which requires you to have both Docker and Docker Compose installed, because we're going to be using those Docker containers to run the Cassandra, Kafka, and the related Zookeeper instances for infrastructure. Looking at our Docker Compose file, we can see that first I have declared the Cassandra service using Cassandra 4.0. It typically runs on port 9042, so you have to map it. Otherwise, I've added in some additional settings to make it more easy to maintain. Specifically, we're going to be storing the actual Cassandra data on our local file system, so you have the ability to not only look at it and access it with other tools, so that the database data doesn't disappear in between restarts. Zookeeper is only required for being able to run Kafka. Originally, it was for managing Kafka offsets. Now it has some different purposes. Entirely isn't important what it's doing in this case. But for the Kafka example, we're using the Confluent version of Kafka, and additionally we have to add some settings to tell it that it's able to talk to external brokers who can publish to it, and I'm setting all the replication factors to 1 because we're not going to be running a cluster. But just as with the Cassandra data, we are storing the Kafka data locally, which can also be used because the Kafka data is actually stored as raw text on the file system, so it could be useful for sometimes debugging stuff with what partition data went into. For this next part, we're going to use the Docker Compose command, specifically Docker Compose up-d for detach mode, to launch the brand new Docker containers. If this is the first time you're doing it, you're going to see a lot of downloads be happening here. You can see the actual project using Docker Desktop by clicking on it. You can see the individual containers, Kafka, Cassandra, and Zookeeper all running up. Clicking on each one lets you see their logs. Cassandra is the one that usually takes the longest to start up. You'll know that it's done starting up once you get a burst of sudden output, probably 2 minutes in. The reason we need to know this is because we're going to run a command, specifically a Docker Compose execution, which is going to run this CQL command to create the key space we need inside of the database, or for the database. So we've created a key space, we created our entity table, we're creating a key space, setting the replication factor to 1, and creating an entity called myEntity with just an ID and a value. We then need to go ahead and create our Kafka topics. I'm using the Kafka topics command, which is, if you're within inside the Kafka container, it also exists as a command you can run, or you can download the Kafka command line tools. We're going to be creating a topic called myTopic. We can see that it got created, and to further inspect it, if we look in the Docker data directory, we see the Cassandra data. Here's our key space and our Kafka data, where we created a topic with 10 partitions, so you see a directory for each partition. Now we are going to take a look at the Maven POM, or the build for the application. If you're not familiar with Maven, I have a Maven tutorial you can go through to get kind of the ins and outs, but to really summarize it, Maven is an XML file that's used for declaring plugins, libraries, and other types of common capabilities for building, running, checking, and testing an application. At the very top, we can see that we're actually pulling in the Spring Boot parent POM. This is so that we can have all of the dependencies from Spring Boot available to us, specifically for version 3.2.3. The group artifact version and name is just identifying the name of the version of the underlying application, and in our case, we're using some common properties for that we're using Spring Boot 3.2.3, but also we're running on Java version 17. The next section gets with dependencies where you're listing the names and versions of individual libraries that you're pulling into this project. In our case, we're using the appropriate version of Spring Boot, using Kafka streams for sending data and getting data out of Kafka. We're also using the Spring Kafka integration as well. And then for Cassandra, we're using its data stacks driver for communicating with a database, but also bringing in the annotations and other resources needed for Cassandra in a Spring Boot environment. We have general Spring Boot starter project, Starter Web for running web services, and specifically Actuator, which is used for automatically creating a /health endpoint that will automatically detect most Spring integrated technologies like your database and display that as a part of an overall health page used for monitoring. Lombok has become pretty popular in Java. It's a means of using annotations for representing getters and setters. Typically, from a Java perspective, if I have a class and I have a member variable that's private, for example, name, I have to declare two public methods, one for getting the value of name and one for setting the value of name. Lombok allows you to use annotations to prevent having to create those additional 6 lines of getter and setter methods. We're using JUnit for unit testing. And otherwise, we're specifying to use the vintage JUnit engine because we're using JUnit 5. As a final dependency, we're using something known as OpenAPI. This was formerly known as Swagger, and it's an automatically generated web page that works a lot like Postman in a sense that you can see all of your web services, all the descriptions you added through annotations, but also it allows you to interact with those web services. Next, we have a series of build plugins. The Maven site plugin is used for creating an actual entire HTML site describing all the aspects of your application from test coverage to static code analysis issues. The reports plugin is needed for augmenting the site plugin with some specific reports. We're using the Maven plugin because that's our build technology. We're using Jacoco for calculating code coverage, which you can also use to enforce certain types of standard. Generally speaking, in Java, I recommend enforcing above 85% line coverage, but since this is a demonstration project, I haven't written unit tests for everything, so I actually commented out those rules. More JUnit stuff. Finally, we have something known as the check style plugin. The check style plugin, it allows you to load a set of common rules. In my case, I'm using the check style rules from Google, which you can see defined here in this file, that's defining common ways that you should be writing Java code. The advantage of having this plugin is that if you have it turned on to enforce it, it prevents you from doing things that look like non-standard Java code. Everything from using non-Java file extensions to making sure that you're not having more than 100 codes on a line. We then have the PMD plugin, which is more about common coding practices for Java. That comes from a PMD XML file, which also came from Google, which gets into specific rules and practices you use for writing Java code, what we call standard Java code, where to put tabs, where to put spaces, not having try-catch blocks that have exceptions, blocks that you don't do anything, making sure you're not having too many static imports. This is all about writing standard Java code so that when two people approach a problem, even if they approach the problem differently, the code will still look the same, and it's really about readability and preventing common coding issues. The Spot Bugs plugin is more of the same. We're also using specifically the Find Security Bugs plugin, so this is going to look for additional common coding issues, but also include a security aspect to it. And in terms of formatting, for example, tabs, spaces, do braces go on the line or the next line? No need to worry about it. We have the Spotless plugin. When you run this, it'll actually format all of your Java code according to the Google format rules. This will actually reduce a lot of those PMD and Spot Bugs issues you would normally get because a lot of it's dedicated to formatting, which is something that could be done in an entirely automated fashion. Now we're going to take a look at the individual Maven task as a part of the build lifecycle that we can run. I'm going to be using the Maven plugin for IntelliJ, which lists all of the available aspects which I can run here on the right, from lifecycle-based tasks to for individual plugins. Note that if you're using the command line and you have Maven installed, this is the same, for example, as running mvm clean, or if you're using the Maven wrapper, mvnw clean. In terms of how to just run unit tests by themselves, notice that unit tests have been written for some of the classes. For example, for the Hello controller, I've written a unit test here. You can also run these directly within the IDE itself by clicking on the Run button, and this works for just about any IDE, Eclipse or IntelliJ. You can also run this from a Maven perspective by double-clicking on Test. Because we've also utilized the Jacoco plugin, however, this will actually generate a report which contains information about different levels of code coverage. For example, if you go into the target site directory, you will find a report from Jacoco which gives you down to the line of code level of code coverage. For example, here I'm looking at the Hello service, which I can see is 100% covered line by the unit test for which I wrote. Another example of how something works from a build perspective is PMD in terms of code formatting and code style. For example, if I delete this comment and then run verify, noting that verify actually runs both the unit test, integration test, and static code analysis, my build is going to actually fail due to a PMD issue. This is because the build has been set to fail on any PMD issue. You have one PMD violation. If you then go to the target site directory, you're going to find a report for PMD, which is going to list all of your violations. In this case, I've created a priority 3 violation, which tells me that a comment is required, specifically on line 19. Now we are going to run the application and then get into several ways to be able to tell the application is running and to manually test what we've been doing. To start with, you want to find the main class, in this case, main application, which will, in the case of Spring Boot, always have this annotation Spring Boot application. So we're going to run this, which you can do through all your IDEs. It's going to generate a considerable amount of logging output, but eventually it'll stop and you'll know that you're now up and running. The first and best place I go to check connectivity is the Spring Actuator Health page. You'll see here that it's the /actuator/health, which we get by including that actuator dependency. This is going to tell us things like we are connected to our Cassandra database, that we're up and running, and what we have available, and our general readiness state. Notice that I don't have the Kafka information here. That's because I'm not using an integration that's compatible with the Spring Boot or Spring Integration actuator. If you go to the Swagger UI index.html page, what you will see is the Open API definition page. This is what we can use to directly invoke our various endpoints that we've established. Let's start by walking through the controller class. So a controller in terms of Spring Boot accesses the thing that is going to be the RESTful endpoint. So the controller in Spring Boot is going to be the endpoint facing class. You do this by annotating a class with REST controller, and with inside the REST controller you can use other annotations like get mapping to define that, for example, /hello is going to be an endpoint I can access. And if we see how this works, consider that behind the scenes Spring Boot is handling both intercepting this request, getting the inputs also using annotations. For example, I can take in a parameter of name, doing any other types of service calls. In this case, I'm calling a method within a service, and then returning the end result, in this case the hello response DTO or data transfer object, as JSON. So when we walk through the code, I see that I'm returning this hello response DTO, which is simply a greeting. I'm taking in a optional parameter of name, and I'm using that and passing it into the hello service. When I click into that, we can see here's where the actual logic resides. And this is very common to do within Spring, which is to have service classes annotated with service handle what we would normally call the business logic. Again, the purpose of the controller class is to focus on establishing the actual endpoint format and possibly validation rules, while the purpose of the service class is to execute some sort of logic. The logic in our case is that if we're given a name, we say hello name. If not, we just say hello. To test how to invoke this, we can click on the hello part of the Swagger UI, hit try it out, and if I enter no name and hit execute, I'm going to get back the greeting hello. But if I enter my name, then hit execute, I'm going to get hello John. An important part of this page is it's giving you how to do this at the command line with pure curl. It's telling you the exact URL involved, and it's also giving you the actual output, along with allowing you to kind of enter in your own parameters and execute this within the application itself. Moving on, let's take a look at the save endpoint. The purpose of this endpoint was to demonstrate how to create a record and store it in Cassandra. In this case, when this endpoint's called, note that I'm using a post mapping. This is because from a REST perspective, we use the HTTP verbs of get for getting data, put for modifying data, post for adding data, and delete for deleting data. And it's these annotations which we're using to model the REST behavior in terms of the endpoints. So this one specifically takes a required parameter of value, which we pass into the storage service. And we come in here, we see that what it's doing is it's constructing an entity. In this case, it's a Cassandra entity that just has an ID and a value, the value we're giving it. And we're giving it a random ID, and we're passing it into our entity repo and saving it. Notice that if you click into this, you get some very complicated looking Java. This has to do with the Cassandra integration. And if we look at what we're actually doing here, there's a lot of magic that's happening, but essentially what happens is that you create an interface in Java that's meant to represent how you want to interface with your entity or your record set directly. So I'm creating a Cassandra repository and saying it's going to work for my entity, which by the way, its primary key or ID is going to be the string. What this does though is that when I look at how to call my entity, since my entity actually extends all this other behavior, I inherit the basic capability to save the entity as a record, to update it, to add it, to do all sorts of things, and to query it directly just by relying on what the Spring framework provides. So if we go over to save, enter in a value, try it out, hit execute, what happens is it makes this RESTful call, and you can see what it looks like in terms of a post, and the response is it just returns the entity that was created, the random ID along with the some value. So the next question is, well then, how do I validate that this got put in the database? That's when we look at a service that was created from a controller perspective. So I used a get annotation so that get list will work. And what happens is that this is saying that when this endpoint is called, it's going to return a list of entities. And I see that it's calling the storage service.list. So if I click into that, you'll see that I'm just calling the entity repository directly and just saying find all. This is again an inherited method from the underlying Cassandra integration that knows that I just want to return all the records in the database. So when I look at my list operation here in Swagger, when I hit execute, what we're going to find is that it's going to just pull all of the entity records we created in that Cassandra database and just return them. So you can see here it's the same ID and the same value that we put in place. And I can keep doing this. For example, I can come in here and say another value, execute it, then come down here and run list. You can see that now I have a second value being returned. So this demonstrates the basic ability to retrieve and create records of a custom object type within a Cassandra database, relying on the fact that the Spring integration, Spring Boot framework itself is actually handling all of these mapping between plain Java objects or plain old Java objects called POJOs and the underlying database records, and also representing that as JSON from an HTTP perspective. Now we're going to go with the last example, which is how Spring Boot integrates with Kafka. Firstly, we have to understand that Kafka isn't the same as Cassandra or a database. Kafka is an eventing technology which is also most similar to messaging, but it is not the same thing. So when we're talking about Kafka, think of it in terms of publish and subscribe. Still the messaging type terminology, but when I publish a message to a topic, anybody who subscribes to that topic is going to get a copy of that message. So it's more similar to a broadcast. What makes it traditionally different than a messaging system is that event, once it goes on to Kafka, is stored theoretically for any amount of time, an hour, a day, a week, years. And so there's a persistence built into the messaging bus. And that's what makes it fundamentally different and allows us to get into event-driven architectures. To demonstrate how this works, I used a post mapping to create another /publish endpoint. It is going to take 3 required parameters, A, B, and C. These could be anything. I just wanted to have an event have more than one field. Also consider, again, comparing Kafka to a database, we talk about an event. An event is really some sort of identifier followed by any data. It could be anything. It's a name value pair type system. We typically, though, are going to be storing JSON payloads in Kafka, so we can easily pull them out and translate them into Java objects or return results from REST services. So what I've done is I've set up a new service with a publish event that is actually generating my payload, which is just an ID followed by these 3 fields. It is giving it a randomly generated ID and then setting the values for A, B, and C, and then providing that payload to my producer, in this case, my payload producer. This class is actually leveraging the Spring Kafka template, which I'm using to send that message, keying it by its ID to a specific topic, in this case the topic provided in the configuration, as JSON. So if I were to look at the raw content of the Kafka log, I would see an ID followed by a minimized JSON representation of this data input. To see this in action, we're going to go to the /publish endpoint, try it out, give it some values like 1, 2, and 3, hit execute. And what happens is that it takes this message and submits it to Kafka. Part of something that's built into Kafka that we haven't gotten to yet is that it consists of partitions. The topic is broken into individual partitions. In this case, I made 10 partitions. And the default strategy is round robin, meaning that when I take an event and I say, go put it on a topic, it is going to randomly pick one of those 10 partitions. And this is so that it can really load balance between those different partitions. Consider that this is also the level at which we're limited by concurrent application behavior. So when I connect the consumer to that topic, and there's only one consumer, it's actually going to connect to all 10 partitions. And so any event I publish is always going to go to the same consumer. The power in the distribution is if I were to break it up into, let's say, still 10 topics, but I have 5 applications. What would happen is that those different partitions would be split between those 5 different applications. And so every application would have 2 different partitions. So every time I generate an event, there's a potential for that event to go to be processed by one of these 5 different applications. And that's how we selectively do load balancing for data at a really large level. When we look at how this works in terms of consumption, what I've done is I've created a RESTful endpoint, noting this typically isn't how you'd be pulling data out of Kafka, just to demonstrate how an event listener works. So I declared a get/events that returns a list of payloads, and you see that it's calling the SomeListener class.getPayloads. So what I did is I created a standard Spring service as annotated by service, but what I've done is I've used the Kafka listener annotation to say that this method right here, anytime the application's running and it gets an event, it's going to call this method, it's going to pick up the payload, convert it into a myPayload event, and then actually keep track of it in the application's memory using this payloads list. So this means that I'm only able to see events that happen while the application's running, and I just did this to be able to demonstrate easily it pulling different messages off the topic. Also noting that if messages are put on a Kafka topic and those messages don't get consumed, the next time this application starts up, it'll just go ahead and consume those messages, picking up where it left off. To see this work, we're going to go to the /events endpoint and execute it. And what we're going to see is that you can see it's the event we generated with 1, 2, 3. And we can again test this by saying 4, 5, and 6. And now when I run get me all the events, we can see that the application is captured now with second event, this one with the values of 4, 5, and 6. In this part, we're going to explain the details required for enabling Cassandra inside of a Spring Boot application. We'll start with the dependencies. Firstly, we're using the DataStax driver for Cassandra along with the Spring Boot Data Cassandra implementation. This is where we get our annotations for Spring data from. Another requirement, at least in Spring Boot 3, is that you need to create your own Cassandra config by extending the abstract Cassandra configuration. You annotate it with configuration and specifically enabling the repositories. This is needed so that it can detect the various entity classes and repository classes for doing the interaction. Something else I've also found, I wasn't able to get the property files to work, so I had to hard code the name of the key space here, which you could also easily do by just referring to the property file. Relating to the property file, in here you specifically have to define these three attributes: the host, port, and the local data center to use. I was not able out of the box to get the schema creation working, and for some reason the key space name auto creation wasn't working as well. In terms of how to create an entity, at least one that maps to something inside a Cassandra table, I'm using a combination of the Spring data annotations with Longbach. The Spring annotations are things like table, saying, hey, this is the table, and I'm using primary key to notate that this UUID is the primary key of the table. However, because I wasn't able to get key space creation and automated table generation working, I wrote a script as a part of the setup when you're actually provisioning the infrastructure through Docker, which creates the actual key space and creates the actual table. In order to interact with an entity inside this Cassandra database, what you do is you use the Spring data repository annotation and create an interface that extends the Cassandra repository, telling it the entity that you're going to interface with and then the data type of the primary key. This is done so that whenever you want to interact with anything in this table, you inherit all these default methods for create, read, update, delete, and all sorts of different queries. When it comes to using the repository class created, you can use this in any service or component within Spring using AutoWire. AutoWire automatically instantiates the appropriate instance of the class in question so that you can interact with it without having to deal with setting it up. In this case, I've defined two methods that are interacting with this repository. The first one is for adding a generic record, where you see I'm calling the myEntityRepo class in save, and then also for just listing all the entities, where I'm just saying repository name.findAll. Both save and findAll are methods that are a part of the inherited interfaces and classes that I'm using. Also understand that when you're including a runtime dependency such as a database or any database, you have to consider how that's going to function inside of your integration test. That's because when you're writing an integration test, for example this one, that's using a Spring Boot test, it is actually starting up an actual Spring Boot container, which means it's going to be trying to auto-wire all of these various things in place. Now, because of this, you have two choices for how to deal with Cassandra. You can either use an embedded Cassandra as a part of your integration test, or you can disable it. In this case, I've chosen to disable it. And the way you do this is a few steps. The first step is, remember how I had that Cassandra config class? Inside my testing space, I created the same class name, but it's empty. This is a Java intricacy. But essentially, I have two classes of the same name on the same class path. And what ends up happening is that I'm actually overriding this Cassandra config with this one. So it's essentially disabling the Cassandra configuration. That by itself isn't enough. Additionally, as a part of my base integration test, I've specifically excluded the auto configuration of a couple of the Cassandra classes. But that also still isn't enough. If you leave it at this, you're going to get an error about some Cassandra template. So I used Mockito in order to mock my actual entity repository. And in doing this, that means if inside my integration test I want to actually interact with my repository, I have to use mocking. In this next part, we're going to go into the details of what it takes to configure a Spring Boot application to send or dispatch events to Kafka. We'll start with the application property file. Here we can see that we're using the Spring Kafka integration to define things like the client ID, the key serializer, and the value deserializer. Notice here that this doesn't have a Spring Kafka. This is because it's manually defined. So in our case, we're adding to the configuration that we're only going to be dispatching events to a topic called myTopic. The client ID is just what's attached to the event metadata in regards to what specific application produced it, for which we're just using the Spring application name. In terms of the Kafka integration in the dependencies, we're specifically using Kafka streams for streaming data out of Kafka, and then otherwise Spring Kafka for other interactions like sending data to it. Considering that Kafka is really a name value pair type store, it's meant to store anything, which we typically do with JSON. In this case, I've created a Java class which contains an ID and then 3 fields, A, B, and C, Alpha, Bravo, Charlie, used for representing the data. The intention here is that the ID is going to represent the key for the Kafka event, and then otherwise we're just going to convert this entire thing to JSON and store that as the actual value. When it comes to putting data in Kafka, what we're going to use here is something known as a producer. In this case, I just created a Spring component, and I'm auto-wiring in what is known as the Kafka template. The way this is working is that we're using the Kafka template to send a specific payload, in this case my payload, into a topic, keying it with the given ID. Note here that the purpose of the ID in Kafka has to do with the partitioning strategy. So it's important to understand that when producing data into Kafka, awareness of how the topic of partitions work. Specifically, that you can have a topic that is then broken into multiple partitions. By default, when I dispatch an event to a topic like this, Kafka is going to automatically take that ID and use it as a round-robin type hashing algorithm, so that if I have 10 topics, it's going to selectively, based on that key, decide which partition to put my event into. This means that if I keep having the same ID over and over again, it's guaranteed it's always going to go into the same partition. The reason this behavior is in place is because in some cases you may want to use a custom partitioning strategy, where for example you may want to put users 1 through 26 in partition 1, 27 through 50 in partition 2, and so on. Also note that we're converting this to pure JSON when storing it in the topic. Now we're going to walk through what it takes to configure Spring Boot to be able to stream events from Kafka. In this case, we'll start with the Maven POM. We are using the Apache Kafka Streams library along with the general Spring Kafka integration. In terms of the property file, the most important parts here are with the topic name, which again is not a part of the Spring Kafka configuration. We're manually defining it inside of our property file, but we're then going to auto-wire it into a property. Starting with the first part of the configuration is what's known as the auto reset. So the purpose of this property is to tell the application's Kafka consumer how to behave when it starts up for the first time. What I've done is I've set it up to latest. That means if there are a million events in the Kafka topic when I connect to read it as a consumer for the first time, I'm just going to start from current. I'm not going to have to read in all those events prior. Otherwise, there's another option you can use here if you want to read from the beginning of time. This is an important consideration because, for example, your application may not be able to process a million events in a reasonable amount of time. The next property has to do with the consumer group ID, which we're directly mapping to the Spring application name. This has to do with the functioning of a consumer group. Consider that a consumer group, when it attaches to a topic, that consumer group is going to share all of the partition consumers across everything else sharing that same group ID. That means if I have 2 application instances both sharing the same group ID for a consumer, and there are 10 partitions, it's very likely one will get 5 and the other will get 5. If there's only one application, that one application instance will have all those 10 instances. This is important because it's how you distribute load and do parallel processing across a topic using those partitions. To handle streaming events from a topic, I've set up a general Spring service called SomeEventListener, where I'm auto-wiring in the topic name. I'm also keeping track of the group ID. Note though that if you're dealing with manual offset acknowledgement, you will need the group ID to be able to tell it where the consumer is in the stream. Otherwise, the primary function of this is using the Kafka listener annotation, telling it what topics to listen to, in this case the one topic, and then associating it with that group ID. What's happening here is that whenever an event is put onto the topic, it's going to invoke this method where I'm getting some generic type of consumer record, which is just a key and a payload. And what I'm doing here is I'm pulling out the raw string from that actual event payload, and I'm mapping it back to my payload class, which is just an ID in the ABC fields. Then, in order to demonstrate this, other than just logging it to the console, I'm maintaining a list of payloads that have been received since the application's been up and running.